Hi guys, welcome to the channel. Let's talk about the tech stack for indie hackers. A lot of developers want to deploy something on their own, to develop some project, publish it online, starting getting users, probably generate some revenue, etc. But when we thinking about those things, there's so many choices we need to make, how we deploy things, what language we use, what framework, etc. And today I want to share my view on the topic. I'm not saying that it's 100% correct. There are different approaches, but that's what I personally tend to use, and I think it's a pretty solid approach. Let me know what you think in the comments, and also if you prefer a text version, there is a blog post I wrote a while ago, and the link is in the description. Let's get started. So first thing we need to think about is where we deploy our code, right? My approach here is really simple. All we need is a single cheap VPC. So we will get our VPC and we will use that to deploy multiple projects. I think it is really nice amount of resources we're getting for the money we pay, right? It won't be zero cost per month, but for example, if we go to Hetzner and we pick the cheapest VPC available, it will be plenty of resources there, and you'll pay something around $5 per month. So I think that's really good. Once we get our single VPC, we don't want to manually operate it. And the thing I suggest we do is first we install Coolify. So Coolify is open source. It's an application that will help you to manage your deployments, right? So first thing, go to your VPC, install Coolify. Once you've done that, you will get UI something like this. That's my host, and here I have some projects running. So for the code, of course, we're going to use GitHub. And if you do open source, you can have public repository, but also you can have unlimited private repositories. And once we created our repo, we will connect it with Coolify. So it's quite easy. In the Coolify UI, you just add a new project and you say that the source is in GitHub and follow the steps. And after that, we already have a connected CI/CD pipeline in some way. Also, Coolify will build our projects on the same Hetzner VPC, so we don't need to use any extra tools like GitHub Actions and some place where we store our artifacts like Docker images, etc. We're just utilizing our cheap VPC to the fullest. So the flow here will be we push some changes to our main branch. Coolify is notified from the GitHub webhooks that there is a new commit, and it will start the deployment process. There's two ways to package things in Coolify. One is Docker. You need to provide a Docker file, or there's a thing called a Nix packs, I think. I just tend to use Docker in my projects. So that's the first thing. We connected our repos. We have our applications running in Coolify. What else we get from Coolify is that we can create a load balancer or reverse proxy that will configure free SSL certificates for us. So we don't have to manage that. That proxy lives on the same host as well. And we can use custom domains and point that into different applications. The users that's calling our project will have a nice HTTPS connection, which is nice. And again, no extra cost here. Now let's talk about databases and what to use for storage. So I just tend to use Postgres in 100% of the cases. So I know there's SQLite, which is a nice option as well. I just really enjoy Postgres for its flexibility. And also, as we'll talk about the path for scaling, if we got lucky and we're getting more users, I think Postgres will just simplify that bit as well. So regarding Postgres database, you can use Coolify as again to create your database instance inside the same host. It's just like you go to new and then select a database type you want, Postgres, MySQL, etc., and it will be running on the same VPC in no time. Regarding the flexibility of the Postgres, what we can use is actually we can use it as normal relational database, main use case. If you want to store some documents with flexible schema, there is a JSON support. You just do like a JSON-B or JSON-B column, and you can put whatever JSON payload you want inside. Then you can build, if your application needs some kind of a queue, you can easily build that on top of Postgres as well. So it won't be like a proper messaging queue like RabbitMQ queue or even Kafka, like a log, transaction log. But a simple queue for application, you can do that in Postgres with a couple SQL statements. I have a video on the channel if you're interested in. Then, if you want full text search, the Postgres built-in full text search is good enough for any solo project you're building. And again, as I mentioned, there is a clear path for scaling. I will talk about that in a bit. One thing I suggest doing is actually enabling the backups for the database. It is done by Coolify as well. You just go to the database and backups, and then you can configure it to run on a particular schedule, and your database backups will be uploaded to any S3 compatible storage. I just use S3 from AWS, but there's other ways. Probably you can just use something from Hetzner with a similar API. So that's regarding the infrastructure. As you can see, we have the single VPC. We paying a bit of money for that, but we're using that to the fullest. We don't need to create extra CI/CD pipelines anywhere. We just use Coolify on the host. Then we can create a single instance of the database or multiple databases on the same host, and then we can deploy one or many applications on the same host. Don't worry about scaling yet, because the biggest mistake you can do is when you're creating a new project is to start thinking about scaling straight away. Probably your application won't get enough users anyway. And if you're lucky and you see a lot of traffic, you'll have a bit of time to scale it up. And we'll talk about that at the end of the video. Moving next, we have languages and tools, right? And here, there is no right or wrong decision. The first rule, if you're just trying to build something and your focus is to actually producing the result, just pick something that you are comfortable with. If you have a different goal, if you want to build something, spend a bit more time on that and learn some new technology, it's fine as well. That's how I learned Clojure at the first place. I just wanted to build something on my own, and I thought I want to learn Clojure as well. And I spent a bit of more time, but I created the project in Clojure, and I learned quite a lot. But if you're just building to get a quick release and quick iterations, just pick something that you're familiar with. For my personal preferences, I just tend to use dynamically typed languages for my personal projects. So on the backend, if it's a really heavy backend application, I'll just probably pick Clojure. It's dynamically typed and I can really iterate really fast. It won't be wrong just to pick JavaScript, TypeScript. Obviously, TypeScript is a type language, but it's in the same category, really, because you can use those types when you need them and don't use them when you don't. So I still consider that in the same group of languages. And also Python, right? Who is familiar with Python, you can just use FastAPI or something like that. whatever is popular there, and build something really quickly. Again, don't worry about language performance, all that stuff. It doesn't matter. Regarding frameworks, my suggestion here as well, use something that you're familiar with or something well known. Don't go too niche or too extreme. One example will be just if you build something that is heavy front end, like SPA, or like some part of your application is like an SPA, just pick React on the front end. You'll be able to use a huge ecosystem of components, designs, components, etc. A lot of libraries, a lot of predefined components. You can just iterate really fast there. And lastly, about tools, I suggest you utilize AI nowadays. It's just really helpful. Just ChatGPT for the inspirations, like, I don't know, design the data, like table schemas for me or something like that. Don't just trust it 100%. Review it as a developer and then pick the parts you liked and iterate on that, right? As well, I'm using more and more code assistants. I'm using the Juni from JetBrains because IntelliJ is my main IDE. Like a lot of people enjoy Claude with this CLI assistant that works well as well. And there's a lot of tools. Like if you VS Code user, you can just use Cursor on Windsurf or whatever. There's a lot of things. But I think you shouldn't just do this hype wipe coding stuff, right? Just don't trust your AI generated code 100%, right? Because you will get in that loop when you create a new feature and then you lost how your project works, and then AI will just remove a bunch of other features trying to fix that particular one, and then you're in this loop convincing AI to actually fix the feature and then keep everything else as is. So always be on top of that, be responsible for the result. Iterate, ask AI to generate some feature, then carefully review that, manually adjust the code, then commit it, and then move forward with small iterations. Moving next, tests, monitoring, observability. For tests, you need tests, really. Like you can go without tests, but at some point when you want to do a refactoring or you want to really iterate and make sure have some safety net once you do the changes, you really won't regret if you spend a bit of time writing some tests. And I'm not saying covering all the code that you write with unit tests. I'm more about high-level tests. One example will be your application has an API, right? So the API level tests will be a good middle ground as I see it, right? You need to test the happy path and when things getting wrong. One example will be like, I don't know, there's an API to create a blog post or something like that. You call that API and you expect those entities to be created in the database. That's how it works. And then you can check that, for example, your API was called with proper authentication headers, something like that. So your only authenticated users are allowed to create the post or do something like that. So you got the idea. High-level tests. Logs. In Coolify, you can just view your logs. You can also configure the logs export if you want them to live somewhere else for more time. That's just to check occasionally. To have better visibility, I tend to use Sentry. In the backend, in the front end, you just integrate it with, it's quite simple to do, and then you'll get a UI and you're catching the errors. So if something is going on, some exceptions are created, you'll have an alert in Sentry that, look, there was an exception, so probably some user experience wasn't great, and then you can dig into the logs and do some bug fixes. And important thing is to configure a health check for your application, just to make sure that, for example, I don't know, the index page is up and running. If your server is down, if your container died or something like that, you'll get a notification that your application is not available, and you can jump in and try to figure out what's going on. Moving next, manage solutions, and here are a couple things. So first, there is nothing wrong to use managed solutions. A lot of things coming with quite good free plans, so you don't need to pay straight away. And the things I tend to use is managed solution for authentication. I had quite nice experience with Kind. I also know people enjoy Clerk, how it's called. Auth0 as well, but probably Auth0 will be a bit too expensive for a solo project. Then obviously for payments, there is Stripe, or I think there are new alternatives available. And just another example, for example, if you want to host user videos or something like that, don't build that yourself. You probably will do a lot of mistakes and it won't be ideal, like Mux or something like that for video backend. And we finally, at the end, so scaling path, as I said, don't think about that too early. But if you see that your single instance is struggling, your latency is up, you have more and more traffic, the first thing you need to do to mitigate that is actually have a bigger instance, so you're kind of scaling vertically, and that will give you a bit of time. But after that, you probably need to have multiple instances deployed. And here are two things. First of all, our storage is a Postgres database, and it will be really easy to move our self-hosted Postgres instance to the managed solution. So we can use Neon or AWS RDS, Aurora, something like that. Just grab your snapshot and restore it in the managed solution. And now all our instances can connect to that database host. For the instances themselves, we already using Docker, so it's just like using the same Docker image, but deploy it in a proper container orchestrator like Amazon ACS or GCP containers, stuff like that. Put a load balancer in front of that, point your domain to the new load balancer, and now you have a horizontally scaled solution. So if that's not enough, you'll have different problems at that point. But basically, that means that your project is doing really well, and it's not the same state as when you just started. All right, so that's all for today. Let me know your thoughts. Actually, one thing is about serverless. So a lot of people just want to go serverless straight away, and it could be a good idea because when you start, you're basically paying zero for some period of time. So if your application has no users, you won't pay at all. But there are some surprises. For example, when there's traffic and you hit some threshold, you could be surprised by the bill. And I think the better usage of money is to pay less, to pay something, not zero, for a Hetzner VPC. But you know actually how much you're paying each month, so there won't be any surprise in the bill. And also, it's just more flexible, right? You can build, you can run some long-running threads on your server if you need it, stuff like that. There are no cold starts. But if you really want to go serverless, I think one of the better options will be the Cloudflare workers and pages and that stuff. So they kind of created a really nice ecosystem, and the developer experience is quite nice, but you kind of committing to be a bit of vendor lock situation, but I think serverless is fine in that case. Just think about the trade-offs. All right, cool. That's it for today. See you next video. Please like, subscribe, and share. Leave your comments. That really helps the channel. Bye-bye.